I hope I didn't crack this speaker cone like this. I'm trying to be so careful with stuff like this. This is actual speaker reconing glue. So this speaker cone is warped anyway. It's probably going to rub. You can see it either got wet here or that's alkaline from the batteries. So let me fix this. This is basically the same stuff that's on this. Anyway, this is a Little Pal 4-tube personal radio. So it runs on 45 volts and 1.5 volts. And it uses these tubes. And it looks like this was made in Japan. It looks like this might have been made by Fujitsu. See how it says 10 on the top of the tube there? I think that's Fujitsu 10. Of course, they made a lot of car radios, and I think we're OEM for Toyota. Correct me if I'm wrong, for a while. This one, the same thing, but trying to get this to work. Someone I know has been struggling with it, young collector. We feature a lot of his stuff here. He seems to provide me with nonstop entertainment, which is awesome. But he has been struggling with this, and there's not a whole lot to these things. So we'll take a look at this when it dries. You'll see it dries clear. There's really not a lot to this. A lot of the magic is done in this couplet right here. It's got four of these 1-volt tubes, one electrolytic. It's where the 45-volt battery connects. That's a capacitor. Yeah, that's a capacitor. Is this multi-band? I wonder why it's got a switch there. And there's the volume control. There's the tuning capacitor. 2 IF cans. It's basically licensed by RCA, so we could probably just look in the RCA receiving tube manual and get pretty close on the schematic. Sam's would not have covered this. At least I really don't think so. I mean, I might look, but it's really doubtful. These things were kind of in that transition between tube and transistor, and I don't think they wore along very well because they used batteries so quickly. It's always a good idea just to start by pulling these tubes out and testing them because the filaments are very fragile and you can't see them glowing. So we're just going to do these real quick. This is the 1R5. So it is alive. The 1U5 is good. The 1T4 is good. These are all 1 volt. If I said 6, that's just habit. This is actually a 3S4, which is a center tapped 3-volt filament. So technically it's a 1.4 volt tube. So all the tubes test okay. None of them are dead. Since we don't have the case here, which I wish we did, we got to go by this. So I guess that is not a band switch. It's earphone off, high and low. As in maybe it has like some sort of a low pass filter to cut the highs off. I don't know. But anyway, that's what this switch is. Glue is still drying. That cone, this thing's probably going to rub anyway. See how the cone's all like warbly? So it looks like we're going to have to give this power and try and diagnose it. And this is not going to be easy to work on. Do we want easy? Hell no. He was asking me to read this capacitor. And this is a weird one. Is that 903.09? And then I thought black was the voltage. Or is... I don't know. This is a weird one. But 903. Or it could be 9 gray, if that's white, gray, black. Just for the fun of it, I'm going to send Bob Anderson a picture of this and see what value he comes back with, since I'm already scratching the colors off of it. You know, and I get this under some high CRI light. So why I like working outside, but that looks like green black. So maybe that's 500 volts. Or maybe that's white, green, black. That looks more like silver to me. So maybe 10%. I don't know on this one. I don't know. 0.09 at 500 volts, 10%. All right, I fixed the capacitor, so everybody should be happy now. I have this set for 1.5 volts and I have it connected to the A battery. And without night vision, you can't see these things glowing. And I might pull it out so we could look at that. But you got to look at the current. 240 milliamps. Well, that would... let's just take a C cell. C cell's what, about 4 or 5 amps? That would gobble that up. Next, we need 45 volts. And I'm looking at this, and I thought that on these type of batteries, this would be positive and this would be negative. At least if it's the same as a 9 volt. On a 9 volt, the small pin, this pin, we'll call that the male, is positive, and the female is negative. So that would mean these colors are reversed. Am I looking at that right? We're going to take the 45 volts off of this, because this supplies everything. And I'm going to hook it up the way that I believe, which is that this side over here with the red wire is negative, and this side being the female is positive. So here we go. Well, it certainly sounds like it's working. So I definitely got the polarity right here. Yeah, don't trust colors all the time. Color will lie. I guess we need to see what frequency the oscillator is running at. Okay. Maybe it's about time to start charging this. So let's see. Frequency center. This should be high side injection, but I don't want to. Let's just put 1 megahertz. So what is our... Let me tweak this. I have a feeling the oscillator is not running in this. I think it's probably just picking up. So look at this. That peak right there is KNX 1070. See that? That's actually the radio station. These are all the AM radio stations we're seeing here. But the peak, which this will always put that frequency identifier on the peak, which is 1070, which is KNX. So that's just picking up the radio station. But I certainly don't see any oscillator running here. So if we look at that and I rotate this, we should see something. And I just have this wire kind of laid here. But yeah, the oscillator is not running in this thing. So let's go back. mode, and then let's do signal generator. Let's do 455 kilohertz. And we'll do modulation AM. So yeah, the oscillator is not running in this. Sort of suspicious of this IF can. So what would make the oscillator not run? Well, this is the oscillator coil. If this had an open winding, that would do it. If potentially the IF transformer had an open winding or bad internal, being Japanese, these are probably not silver mica capacitors, they're probably tubular ceramic. And these Japanese cans don't usually have problems. So, but potentially with this, in the way when I move this around and it moves that IF can pin and it makes different noises, could be an open in this IF can, could be a bad capacitor, it could be the 1R5 is bad. This, I was just kind of playing with it and it popped off of there. So I think we're going to test a few of these capacitors before we go any further and resolder this stuff. We'll try and ohm out the IF transformer. It shouldn't be much to these. The IF definitely seems awake. I guess it could be a bad resistor, but there's really not much to these things. It's really simply coils and a few capacitors. There's just nothing to these. And the IF certainly seems very awake. Back to this mystery capacitor. So the feedback I got was that it's probably 50 or 500 because you have green-black, because it's too small to be 0.09 unless it's paper. And that these color codes really don't seem to follow the traditional thing for these domino postage stamp capacitors. Well, I got it on the tester. It's 0.09 paper. It is a 0.09 paper. So right there is 0.1, 0.1, 0.05. See this? And see how we don't get a really good clean eye opening? That's because it's a lossy paper capacitor. Let's do a leakage test, and I'm not going to go too high. I'll do 50 volts. Oh, it's leaky. I mean, not real leaky, but why did they use a 0.09, not just a 0.1? I don't get that. I don't think that capacitor, is that just a surplus thing where they had a bunch of those? I don't know, that doesn't make a lot of sense. I wish I knew where it was in the circuit. It obviously is probably not critical if it's paper rather than mica. Yeah, just because you see this style, don't suspect it's going to be mica and that it's good. That's a paper and it is no good. This one here is 5 picofarads. All I can really measure is that it's not leaky or shorted, and it's not. It's good. This is just to dial in the, to help dial in the trimmer capacitor there. I think the next step is to start checking some DC resistances. See if I can, identify if one of the IF transformer or the oscillator coil has an open winding. All right, I'm going to check the first IF transformer. 10 ohms on the first coil. 10 ohms on the second coil. That's not open. Well, I think it's the oscillator coil that's open because I'm measuring between, some of the leads don't connect to anything. That's between two of them. And then 1.5 megs? I don't think so. So two of these leads are completely open. Two of these leads are completely open. There's continuity between these two, but this one that goes to the ground is totally open, and this one that goes to the tuning capacitor is totally open. So I think this is the problem. This thing says licensed from RCA on it, so let's take a look in this book. I think in the back of this are schematics, because RCA designed everything and then everybody just copied it. So let's see if we can get a idea of how this oscillator coil is wired. Here we go. This is probably very, very close. So that's the oscillator coil right there, T1. And that's probably how it's wired in. Don't be throwing no shade. I just want to get paid. So this is the exact circuit here. And this is the coil that's open. This one's good. But C3 is this capacitor right here that connects to the gang of the tuning capacitor. And then over here, R1, which they have as a, it's 100K, 0.1 meg, is right here. So this radio is literally almost this perfectly. This is almost a perfect copy of this. Except this is a 67 volt. And this is a 45 volt. So this is probably the capacitors, and the resistors are probably a little bit different. But yeah, we got an open primary coil in the oscillator. And I kind of know my limits. And that is so damn small, I don't think I have the eyesight anymore, even with magnifying, to cut that heat shrink off of there without damaging this and possibly fix it. I mean, that thing is tiny. The hell with it. The thing is a freaking brick anyway. I might as well just kind of roll it off here. Well, I found the break. And I confirmed it with the ohm meter, and there's just no way. It's right here. There's just no way. There's a hard, like, shellac on this coil, and I can't even scrape through it. So yeah, that coil is a no repair, no fix. This is a General Electric clock radio, or what was a General Electric clock radio. One of those cheap-ass things. Anyway, here's the oscillator coil off of it, right here. And I'm assuming it might work. Well, we're going to try it, because it's what I got. Now, you can see on this one, it's a little different. They have two of the pins connected to ground. So we can clearly see what pin goes where. We line it up here, because the tuning capacitor was right here. It's been removed. So this pin right here went to the tuning capacitor. These two pins went to ground, and this other one, the other pin, went over here to the converter tube. This used a 12BE6. Of course, this uses a 1R5. So the difference is, on this, the two grounds, both coils are not grounded. So I'm just going to figure that out. That's not that hard. I have to get one one side of this disconnected. I have to, because this side over here is open, I'm just going to leave that. I'll have to desolder one of the 4 leads, and then we could use an ohm meter and figure this out. The bigger coil, I believe the bigger coil, and I can verify this, but the bigger coil, meaning higher resistance, more turns, connects to the tuning capacitor. White and green are the 2 leads that were tied together and to ground on here. Between orange and green, we have 7.8 ohms. Between yellow and white, we have a half an ohm. So white, the big coil goes to the tuning capacitor. So green would be ground. Green would be ground. Orange would be tuning capacitor. White would be whatever the low side over here is, and then yellow would be, well, okay, they actually show this is the bigger coil, more turns. So green, this would be green, this would be orange, this would be white, this would be yellow. Maybe I'll try and disconnect this one that goes directly to the tube. That would be this, which would be yellow. So yellow, white, and then ground would be green and orange. Here's our what our speaker looked like after it dried. It's not great, but it is great. It's as good as it was, but yeah, it's really, that cone has really been subjected to some moisture. Anyway, here's the coil. I think I got it installed right. I'm just going to tell the kid to find another coil. If it fixes it, I'm going to take this one back off, tell him find another coil. Play with it, learn from it. I'm sure one of those, vintage radio places online has a coil for one of these type of radios. It's an RCA licensed 4-tube personal radio, battery. I mean, there's nothing special. I don't know if this is going to work. We're going to find out. It might run, but it might run way off frequency, which in that case, I mean, whatever, right? At least it'll run. And maybe it'll tune in aliens or something. We like aliens. And when you're diagnosing radios like this, don't hesitate to just take an ohm meter and check all the coils. Before you even start, check all the coils in the IF cans and the audio output transformer, the oscillator coil. Just check coils with an ohm meter. Just never assume that capacitors are going to fix the thing, because they're probably not. So I'm going to measure across the coils just to make sure I got it right. So this is measuring across the oscillator section of the tuning capacitor. Okay, good. We have our 7 ohms there. And here's measuring across the one that connects to the tube. We have our half an ohm there. So let's put power to it and see what it does. Here we go. To remind myself that the wire colors are reversed here. So did I hook this up right? That's a positive, a negative. This should be ground, or B negative. Alright, what did I do? Well, it looks like I might have accidentally stroke-o-brofulated something here. And I don't know how I did that. Are those that fragile? Green, black, red, or green, black, brown? Green 501, 500 ohms, or 5,000 ohms? I'm going to try and measure it here just by sticking it in the end of the... Well, I don't know. I don't know. If I measured this one should be 100K, right? Yeah, that's right. 100K. This one should be a meg. That's probably about right. I don't know if that's red or a brown. Do we have anything that looks red here? I don't think so. Let me try and figure out where it is in the circuit. Okay, there's a 5K. Just too much of a brute force American pig to work on this delicate early Japanese stuff. I don't see how that could make it quiet, though. I mean, there's no hiss or nothing here. Okay, well, I just learned something here. This might actually be a 500 ohm because it comes right off the negative, but these wires are not reversed. They loop under. They're crossed. So the red is coming over to here, and the black comes over here as a strain relief. So had a Jason J.J. Cruz moment there for quite a while. I'm going to try a 500 here because I'm looking at the way it's wired, but I still think it should make some noise. So speaking of, I drove my Cruise bot to the levee, but the levee was dry. I created a channel on Rumble because, I wanted to be where all the cool kids are with big desk microphones. And I thought this would be awesome, be able to post videos and, not have to worry about having more than 5 seconds of some music clip or something in there that would destroy the whole video. So Rumble had a thing where it would automatically download the videos weekly from YouTube. Well, YouTube blocked that, so kind of killed that whole idea. But the damn Cruise bot showed up on Rumble. Damn, man, what a professional frickin' troll bot. Anyway, Cruise-tastic. Okay, I bridged like a 700 in there. Let's see if it makes any noise now. Oh, okay. Sort of the same. Maybe this oscillator coil is just not compatible. Actually, it's a little different. Let me check my work. I'm going to try and flip these two wires, even though it looks like I got everything connected right. I don't see why it wouldn't work. I really don't. I got the old one out of circuit. It's definitely awake. Yeah, I'm going to try and flip it. I don't know if that would stop it or not. Pretty sure I hooked it up right. I switched it around, same thing. I changed the tube too. I changed the 1R5. Didn't make a difference. I mean, I don't know. Maybe it's just a totally different oscillator. Look at the size difference in the coil. Now I'm checking the tuning capacitor. I disconnected one side of the oscillator coil. So I'm going to adjust this. You can see when I adjust this. So if I bring this down, then I should have to bring this down. So this thing looks like it's all the way closed. All the way closed. It looks like it's 200 picofarads. Is that about right? Yeah, that's about right. I think they're, I don't know, it's in the book, but I'll open it all the way. So it looks like it goes from about 100 to 200 picofarads. Now this thing is not that accurate, but at least it shows it's not shorted and it's working. Well, this says 7.5 to 122.5. So this oscillator coil might be a gross mismatch for that. So couldn't we just get another tuning capacitor and clinkotrochulate? I think so. So 2 should have power, and 3 should have some power. Isn't this fun? Let's check voltages together. So I think this is 2. So that's the plate, and then 3 should have some power. Why do we have so much voltage on 3? 2 should be the plate. Well, we have 39 on the plate. We have 39 on G2 and 4. It's weird, it just won't oscillate. I mean, what is so damn hard about oscillating? I mean, usually these things will oscillate in their nightmares. The reason why this is measuring so high, I believe, is there's the feedback capacitor right here. Right here is the feedback capacitor. I'm going to disconnect all of this crap. I just can't believe, I know this is different, but I can't believe it's that different. I mean, I know it's bigger, but it's an air core versus an iron core. This has a slug in it. And it just might be too different. You know, if it's not in the zone, it won't run. Well, that little feedback capacitor there is right on 56. About 56, which is what the book calls for that capacitor. Let's see if there's any leakage. And I only need to go to 50 volts on this. No leakage, because the radio only uses 45 volts. And yeah, now with our everything disconnected off the tuning capacitor, it measures what it should from about 120 or something down to nothing. Well, I've literally checked every component in this, so I'm going to try it. And I'm working on a whole video with these solid state tubes if I could get the guy to finish helping me out. I've been holding off on releasing the video and for months, trying to get some bugs worked out. I'm reluctant because the radio doesn't work, but since everything checks okay, these have a very wide bandwidth, we'll just call it, to oscillate. Okay, here we go. I'm going to apply power. These are expensive, so... It behaves almost the same. So bizarre how this thing will not oscillate. so bizarre. I've checked everything. I checked both tuning capacitors. I checked all the other capacitors, all the resistors, all the coils. Yes, that oscillator coil was open. I just can't believe that this one is just not close enough to do something. I mean, it might oscillate way off frequency, especially with this tube. It's just like a big TRF set. It's not heterodyning. Here's a different coil I found in the stash, and it's only 3 leads. So what I did is I hooked the common point up here. So that will essentially apply voltage to this, but does that really matter? Because I don't know. I don't even know if it's the right coil. Ooh.
Existing home sales report from the National Association of Realtors. Thank you, Lawrence. Thank you. You're very welcome. Lawrence Hume, the chief economist at the National Association of Realtors.
And the first thing that comes out of it is the National
Yes. One catch, one can't. Don't say that, Michael. Don't say that, Wilmy. Don't say that. Next, on our special... And we tell them, look, you can't let them on city council. You can't let them get a foothold on your school board.
Nope.
Or your water board. You can't. You're so right. Once you do... That's going on. There are active fights about that right now. I mean, yes. Really... because these people who move take our attitude. Most of them.
I think what we have is we need to tune this.
Yeah, that's kind of right, no matter.
Really,
There's a famous quote from H.L. Mencken. If somebody says it's not about the money, it's about the money. Yes.
So what it is the oscillator is so far off that we can't adjust the trimmer capacitor on the tuning cap and actually get it to work. So I'm trying to figure out how to do this. Like,
every time you buy gas, use promo code SPEED.
doesn't seem too far off, though.
VIP Scholars Program, which we'll get into, as well as the freshman transfer.
With temperatures warming into the 70s, with Southern California's most accurate and dependable forecast. I'm KCAL News meteorologist Alex Biston for KNX News 97.1 FM.
Well, it's not the right oscillator coil, but it's running. We can take a look at it on the Scoily Spoimler. So we can figure this out. I think you're supposed to adjust it to, I don't know, 6, what's the bottom of the AM band? So what I need to do is, it's running way too fast, 2.5 megahertz. 1610 plus 455 would be 2. High school education. Get telephone to ask stupid question. 1610 plus 455. 2.065 megahertz. So with this all the way open, it should theoretically, we need to slow it down to 2.065 megahertz. You can hear it waking up. Probably not going to get it very close. Getting closer. Stand by. Boy, everybody's about to get excited. Here she is. There she was. It's still too high. But the sensitivity is there now. Volume control is bad.
Significant population change, and David Welch reports the state that people used to dream of moving to is quickly becoming a place that's out of reach.
California is increasingly made up of people who were born here. Numbers in a moment, but the idea is
Really?
important because of what it doesn't say. Dreamers, pioneers, seekers of you name it. They simply aren't moving here.
California is just a very expensive place to live.
Eric McGee is a senior fellow with the Public Policy Institute of California. He says recent census data reveals that the number of adults born in the state hovers around 48%. That's nearly double what it used to be a century ago.
Garbage excuses for bad politics. Ooh, look at, there's a harmonic there.
And sell and rinse and repeat, do the same process over and over. That's another thing that you could do is every 2 years move or buy a duplex.
I credit Dan Campbell to bring it up.
That little spur is interesting.
Kind of goes with what Coach was to say.
I think too we've become accustomed to who Baker Mayfield is, not?
Well, it's working. It's been resurrected. It's been diagnosed. We know what the problem is now. The problem is the oscillator coil. I confirmed it. Now it's just about getting the right one because, like I said, I could show on the schematic. That oscillator coil that I ended up using, these two were tied together internally. So what I did is I just tied them to here. I don't have this one connected to ground. Now there's voltage here because this is the plus, right? Comes over here up through this resistor to this coil. So now it's also bridged to this coil. So this is hot right now. We have B plus on this point, which is okay because this capacitor isolates it. But these plates of the tuning capacitor have full B plus on them, which I don't think you want, ideally. Look at that oscillator, man. That thing's really cranking along. Look at that. So I have this tuned on this is a test station, and this is a Caltrans road information, highway information sign. Caltrans is California Transportation. They're who do our roads here. And I always get a bunch of questions, what frequency it's on, what is it? So that's what it is. So I'll let you use your telephone to do the math. 2.155. 2.155 minus 455. Assuming that that the IF is aligned perfect onto 455, and that I have it tuned dead on. 2.155 minus 455. Let me fix that solder joint that broke.
sponsored by O'Reilly Auto Parts.
I'm Stacey Lynn. This just in, Florida Governor Ron DeSantis has dropped out of the race for the Republican nomination for president.
I can't ask our supporters to volunteer their time and donate their resources if we don't have a clear path to victory. Accordingly, I am today suspending my campaign.
And he's backing the former president now.
Trump is superior to the current incumbent, Joe Biden. That is clear. I signed a pledge to support the Republican nominee, and I will honor that pledge.
Meanwhile, at a campaign event in New Hampshire, Nikki Haley responded to the news.
I will do everything I can to prove to you that you made the right decision. But for now, I'll leave you with this. May the best woman win.
She's been in the state all weekend making last-ditch pitches on why she should be in the White House. CBS's
Because she could loot more money and put it in her pocket.
Supporters of Nikki Haley, I've talked
She'll bend over for more lobbyists than anyone else. Anyway.
And overwhelmingly, they have told me that they believe that they see their vote as a vote against Trump.
So that dates the video. So anyway, we can put a wrap on this. It sure has been a long video to try and diagnose and get a coil in there that would work. What I'm going to do with this is I'm going to put it back to as close to what it was when I got it as I can. I'm going to replace that resistor I broke. I think I need a cigarette. I'll put a 470 in there, and I'll try and hook the original oscillator coil up. And it'll just be his project to try and put find an oscillator coil for it and get it to work. We know that the big air core one from a standard All-American 5 will not work. So it's gonna. I wonder if one from a transistor radio would work. I don't know. A red core. I don't even know what that one is for. But I do know it's not the right thing, because it needs to be two separate coils. So it's a good project for him to play with it and learn. Everything else works okay on the radio. This capacitor right here, I would just replace that with a 0.01. Actually, no, a 0.1, because it's... I would just replace that with a 0.1, not a 0.09. I don't know what that's about, if that's some surplus crap. And yeah, just button it up and do all your adjustments on it and get it dialed in. I think it's gonna work with the right oscillator coil. Okay, to recap, the speaker had a tear in it. I don't know if I did that, or I don't know if the middleman did that when I got it. I fixed that. That's good. The speaker sounds clean. The oscillator coil was open. The side that connects to the variable capacitor was open. Took it apart, tried to do it, just couldn't do it the way it's laminated in this epoxy. You can't do anything with that. I broke the 500 ohm resistor. I replaced it with two 1K resistors. My solder looks good. That'll never fail. I checked it. It's 500 ohms. This oscillator coil out of a regular All-American 5 style GE, whatever. These are very common, and 12BE6 sets. This did not work. This mystery coil that I found, this did work, but it's not right. So what this radio needs is it needs the appropriate oscillator coil, and then just the alignment of the oscillator coil and the trimmers on the tuning capacitor, and that's it. That's the full diagnosis. We saw it working. Good to go. So the owner gets the fun of figuring the oscillator coil out.